Hey guys, welcome to section 4.5, day 4. We are still here working with exponential and logarithmic equations. So we will be solving algebraically today. So let's review some of these tips for how to do that. The first bullet point that we want to remember when we solve algebraically is to cancel out logs on both sides. If we have a log on the left of the equal sign, log on the right, they can cancel out. Our second bullet point, combining logs into one. Remember, if we have logs being added, we can combine those with multiplication. And if we have logs being subtracted, we can combine those with division. My third bullet point here is a reminder to rewrite logs into exponential form. So we want to be very comfortable going from logarithmic form to exponential form. And then just the last reminder, this is going to be more for our answers, that you cannot take the log of the number 0 or of a negative number. So when we get our answers, you just want to plug those back in to make sure that they're okay and they meet both of these requirements. We will be doing a little bit of factoring today, so just a review with that. When you are factoring traditionally for working backwards, you want two numbers that add to the middle number and that multiply to the last number. So for example, right here, we want two numbers that add to -6 and that multiply to +8. The signs do matter. So my two numbers would be x minus 2, x minus 4, because -2 and -4 multiply to +8, add up to -6. So if those are my factors, that means my answers are x equals +2, x equals +4, because to get those, we set each factor equal to 0 and solve. Okay? Now keep in mind, if you can't factor, okay, then you have to use the quadratic formula. We will be using that a few times today. And so remember our quadratic, -b plus or minus the square root, b squared minus 4ac, all over 2a. Okay? And you guys are pretty good at using that and just plugging in. So let's get into the first of our 3 examples. And here we go. Solve each problem algebraically and graphically. Again, we're focusing on the algebraic piece. Round answers to 3 significant digits. So the first thing that I'm going to do here is I'm going to combine my logs. So since I have subtraction on the left, then I could combine those logs using division. So log of x divided by 5 equals, again, I have subtraction on the right, so I can combine them using division. So log of x divided by 5 equals log of 2 divided by x minus 3. Okay? Now that we have done that, we have log on both sides, so I can just cancel these out. Okay? So now I have x over 5 equals 2 over x minus 3. Now when we have two proportions like this, remember we can just cross multiply. So I'm going to have 2 times 5 equals x times x minus 3. We're just cross multiplying. So I end up with 10 equals, let's distribute here on the right, x squared minus 3x. Let's subtract 10 to both sides, because remember when you have a quadratic, the x squared makes it quadratic. You always want to get one side equal to 0 in order to solve. So once I subtract that 10 to both sides, I get 0 equals x squared minus 3x minus 10. All right, so let's go ahead and factor. I need two numbers that add to -3 and that multiply to -10. So my two numbers are going to be -5 and +2. So I write those as my factors. I set each factor equal to 0. And so then, for my answers, I get x equals +5, x equals -2. Now be careful. Go back to the original problem over here in the top left. Can I take the log of a negative number? One of my answers was -2. Can I take the log of a negative number? No. So that means -2 is not one of my answers. So the only answer you guys would tell me is x equals 5. Okay? And be mindful of that because, again, that's kind of a tricky part of it. But make sure you always double check those answers to make sure they work. All right, let's go to our second example. So here, again, we're going to solve this algebraically. On the left, I'm just going to keep my ln of x. But on the right, since these logs are being subtracted, I'm going to combine them using division. ln of 2x minus 1 divided by x minus 2. Now, since I have natural log on both sides, they can just cross out. So now I have x equals 2x minus 1 over x minus 2. In order to get rid of any fraction, we just multiply by the denominator. So on the right, they cross out. Make sure we do it to the other side. So on the other side, what we have now is x times x minus 2 equals 2x minus 1. So let's make sure we distribute. And I get x squared minus 2x equals 2x minus 1. Now that we have that x squared, that quadratic, so now that we have this x squared quadratic here, we want to make sure that we get 0. So let me subtract 2x from both sides to start getting us close to 0. So now I'm going to have x squared minus 4x equals -1. My last step to get to 0, add 1 to both sides, and I end up with x squared minus 4x plus 1 equals 0. Now, it would be awesome if I could just find two numbers that add to -4 and multiply to 1 and factor. Unfortunately, that's not the case. Okay, guys? So we're going to have to do the quadratic. Remember, for the quadratic, the first thing we want to do is identify a, b, and c. A comes from the number in front of x squared, so a is 1. B is the number in front of x, so -4. C is the number at the end, so 1. Let's just go ahead now and plug all of that into the quadratic. So I'm going to have -4 plus or minus the square root of -4 squared minus 4 times a times c all over 2a. Okay? So it looks a little long, but again, you guys are familiar with this. It goes very quickly with simplifying it. As soon as I simplify this, I have 4 plus or minus the square root of 12 over 2. Okay? So that looks much, much simpler. Then, remember, we want to separate this into two problems. So my first problem is going to be 4 plus the square root of 12 over 2. So that's where I'm going to get my first answer. My second answer is going to come from 4 minus the square root of 12 over 2. Okay, so that's where my two answers are going to come from. 4 minus the square root of 12 over 2. So when I do 4 plus the square root of 12 over 2, I end up with x equals 3.73. When I do x minus the square root of 12 over 2, I end up with x equals 0.268. Again, 3 significant digits. This 0 to the left does not count. Okay? So here are my two answers over here on the right, but you want to check them. Since we are taking the ln of x minus 2, if I were to plug in 0.268 here for x, I would end up with a negative number because 0.268 minus 2 will give me a negative number. You cannot take the log of a negative number, so that means this answer would not work. So my only answer here for this problem would be x equals 3.73. Okay, guys? Last problem. So here we go. Problem number 49, solving algebraically. Okay? Now, in this scenario, since I have the 1 here by itself, I want to get my logs on the same side so that I can combine them into one log. So in order to do that, I'm going to add that log x minus 1. So on the right, they cross out, and on the left, I'm going to have log 2x plus 1 plus log x minus 1 equals that leftover number 1. Okay, so now since I'm adding these logs, I can combine them with multiplication. Log of 2x plus 1 times x minus 1 equals the number 1. Remember, my default base is 10, so even though it's not there, that's my invisible base. So I'm going to go ahead and rewrite this in exponential form. So my base of the log becomes my base of the exponent. The number on the other side of the equal sign becomes my exponent. So 10 to the first equals whatever we're taking the log of, I put on the other side of my equal sign. Equals 2x plus 1 times x minus 1. So this is where we're at now. Okay, guys? So let's go ahead and FOIL. Over here on the right, I'm going to have to FOIL all of this. And so when I do that, 10 to the first is just 10. And when I FOIL, I get 2x squared minus 2x plus 1x minus 1. Remember, whenever you have a quadratic, that x squared, you want to make one side equal to 0. So I'm going to subtract 10 from both sides to make that happen. I get 0 equals 2x squared. Let's combine my like terms. Negative 2 plus 1 gives me negative 1x, and negative 1 minus 10 gives me negative 11. So here I am. Okay, guys? Again, we're going to have to use the quadratic. So a equals 2, b equals negative 1, c equals negative 11. Let's go ahead and plug that in. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, it's just plugging in, simplifying from there. Okay? So I end up with 1 plus or minus the square root of 89 over 4. Again, it looks much, much simpler now. So I'm just going to break this up into two answers. Okay? My first one is going to be 1 plus the square root of 89 over 4. My second one is going to be 1 minus the square root of 89 over 4. All right? And so once I do that, I'm going to put my answers here at the top. My first answer is going to be x equals 2.61, going to 3 significant digits. So there is my first answer. My second answer is going to be x equals negative 2.11. So there is my second answer. Now, don't forget, guys, we still have to go back and see what would work. If I'm taking the log of x minus 1, if I plug in a negative number, I'm going to be taking the log of a negative number, and that's not allowed. So that means this x equals negative 2.11, that's not a real answer. Okay, guys? So the only answer to this problem would be x equals 2.61. And I hope that makes sense. I hope you guys are seeing why some of these answers aren't appropriate for the problem. Okay? The last thing we're going to look at is, even though the directions in all these problems wanted us to round to 3 significant digits, on the test that won't always be the case. So let's say, for example, we just get an answer of 2.6. Okay, and this is just basing it off number 49, but not necessarily. So if we get an answer of 2.6, your test options will look like this. they won't say 2.6 or 2.61. So how do we know which one is correct? Remember, just put each of these into the calculator, okay? So actually do them in the calculator, right? Do 4 plus the square root of 87, then divide by 3. Tell me what you get, okay? So for example, if I were to do that right now, 4 plus the square root of 87, then divide by 3, I get 4.44. That is not 2.6, so I can cross that out. If I were to put this in the calculator, 1 plus the square root of 89 divided by 4, I get 2.61. That does match up, so I think that's my answer, but let's do my third one just to be sure. 3 minus the square root of 15 divided by 2 gives me negative 0.436. Again, that does not match up to the answer I got, so I know that this is not going to work. Okay, guys? So does that make sense? Be able to go from different formats, whether it's in radical or decimal. So that's it for today, guys. You have your homework here for 5-day 4, textbook page 449. You only have 3 problems, okay, guys? There's going to be a little bit of work there because they involve the quadratic, but that's why you only have 3. So don't get lazy. Make sure you go through them. Upload all of your homework to Google Classroom, all right? And make sure if you have any questions, you put those in the comments as well. Alrighty, guys. Thanks for joining me for this lesson. I will see you for the next one.